Hello everyone, and today we will discuss neural machine translation. I think we started with the example of machine translation in the first lecture, because this is the easiest way and the most illustrative to note the difference, the evaluation of different machine techniques, of natural language processing techniques. So, in terms of machine translation, we will first discuss with you a bit of history of these methods, because there are main three approaches to machine translation, and they are parallel to those supervised, unsupervised learning techniques, data-driven and rule-based. Then we'll go on with the neural translation, trying to figure out how it all happened, that now it's much better than it used to be. And finally, we will discuss some machine translation tools which are user-oriented online, and some professional tools as well. Finally, as a case study, I would ask you to do the work which nowadays even professional translators do, of pre-editing and post-editing the texts, because of course a few years ago it would be impossible that a professional translator would say that they use Google Translate or equivalents, but nowadays they speak about the transformation of this job, because of course they all do use different, normally not just online tools but professional tools, and we'll see the differences between them. But however, the competence is not just about translating nowadays, but it's more about pre-editing and post-editing the texts, and we will try it out today to figure out whether it makes difference or not, because in fact even the free online tools, they are already quite competent. Of course, if we speak about the translation of fiction, then it's a separate story, because even the translator is sometimes considered as the co-author of a novel, for example. So it's absolutely human-like even now. But if we speak about translating documents from business sphere or any other especially structured texts, then of course machine translation can even do without a human. But we'll try to find what the human might add to the translation. So the history, as for the history of machine translation, do you agree that the revolution happened? Yeah? Right, so what it all started with, let's see, and how it all developed. So in terms of machine translation, in the first lecture, the Georgetown experiment was mentioned. So which two languages were processed with this machine at Georgetown University a few decades ago? Which two languages can you see here? Russian, yeah, and obviously English. But Russian was transliterated because it was hard at that time in the 60s for the machine to operate Cyrillic alphabet. And so this Georgetown experiment within the IBM tool, IBM machine, was aimed at translating some scientific texts, and it had kind of a dictionary and was absolutely rule-based, so it was a word-by-word translation. What do you think? Was it successful? Of course, for us today, absolutely not. But at that time, even in the newspapers, there were articles that, okay, it happened that the machine can provide some translation. The worst thing about it is that it takes just the first meaning, the first definition of a word, the first meaning of a word, and translates it only with the first meaning. And we discussed with you during the 5th lecture all the ambiguities which should be beared in mind. In fact, at the same time, in the 60s and 70s, and even starting with the 50s, in the middle of the 20th century, not only Georgetown experiment was performed, but also in Russia, a group of scientists, under the supervision of Professor Lipunov tried to work out a kind of similar machine, translating the pairs of words in French and Russian. So it was again a rule-based translation, and they relied mostly on linguistics, although even back then, according to Professor Lipunov, the machine translation task was more about maths, was more about computing than about linguistics. In fact, after a few decades, at the beginning of the 21st century, especially at the AB Lingua company, they tried to rely more on linguistics than on just computing. However, a few weeks ago, in 2024, a lot of employees lost their job in AB Lingua, probably not only because of these theoretical issues. However, what they say is that now they do not need a lot of linguists in AB Lingua. Hopefully, it's just about developing like a spiral, because, of course, after huge computing powers comes a lot of questions to be figured out by human translators. But, of course, we all know a lot of examples of such translations, and we all came across them in Google Translate and in other tools a few years ago. As for the rule-based translation, rule-based machine translation, which developed in the second part of the 20th century, it was first of all translating word by word. So the unit to be translated was just a word, just one token, and another thing is that, and so from this from this angle, it is rather controlled and might be rather transparent. With the 21st century, the second generation of machine translation techniques started to develop, and that was statistical machine translation, SMT. Here comes the kind of universal language which we mentioned with you during the 5th lecture. Even René Descartes, a few centuries ago, said this about the universal language, meaning that there should be some kind of language in which exist all the ideas and concepts. And so within machine translation, this language is called sometimes transfer language or interlingua. And in fact, all the techniques of machine translation, no matter whether it is rule-based, statistical, or neural, they follow this triangle. It is called Vauquois triangle, after the French scientist who proposed it. And the idea is that the machine always gets the input in the source language, and then first it needs to compare it to the concepts, ideas behind the words in the transfer language, so some kind of context-free language from the formal groups of languages described by Noam Chomsky. And then afterwards, the machine needs to generate, not just to translate word by word, but to generate the new text in the target language. But of course, if we take the performance of the machines according to the rule-based technique, then it would be normally just the semantic transfer, the word-by-word translation of particular words, but still going through this transfer language. So even in the middle of the 20th century, this idea was already realized, but on the level of just words, so just semantic transfer. With statistical methods, which were already possible at the beginning of the 21st century when all the data on the internet appeared and Google Translate and equivalents started to develop, the item to be translated became the phrase. So phrases, whole phrases were translated. So SMT, statistical method, it deals not with the units of words, but with utterances, so with sentences. But it tries to compare the input in the source language to different variants of similar sentences, similar utterances that it has in its corpus. Of course, the corpus of an online translator, it is updated all the time. However, statistical translation, it brought us to all those memes with different mistakes of translation, because unfortunately just statistics doesn't help. So it usually takes a strange utterance which doesn't coincide with the input in the target language. However, with statistical method, as the whole sentences are the units to be translated, then already the grammar structure, the syntax, is taken into consideration. And so machine translation online systems of the 21st century, they took an utterance, a sentence in the source language, analyzed it from the vocabulary and grammar angles, and then tried to choose the best translation from the corpus. That is why we can say that unlike rule-based translation, which is supervised, 100% supervised, the statistical translation is mostly unsupervised and data-driven. So this comparison of the input with the transfer language and the output, it happens on the phrase level, and it is unsupervised because it is driven from the corpus. Is it clear how this triangle works for rule-based and statistical approaches? And then comes the neural translation. So it started to develop 10 years ago with the introduction of language models that we discussed with you, like Word2Vec and others. And the huge difference is that it tries to analyze not just the sentence, but the text as a whole. So it is not a problem, but it is an advantage for the neural network to get a huge text to analyze, because it does not only compare this text in the source language in terms of words and phrases, but it compares the whole context. And we mentioned with you that to deal with ambiguities on semantic and especially syntactic and pragmatic levels, pragmatic level almost was not taken into consideration at all before neural translation. The machine needs to analyze the broader context. So the chief difference of neural translation in comparison to its predecessors is that it works, first of all, with the whole text, not just a word or phrase, and it analyzes the input, translating it into the transfer language and then generating something in the target language not just based on the examples from the corpus or on the rules, but analyzing the context on different levels for different ambiguities. And the mechanism which stands behind this process of analyzing the context is called LSTM. Has anyone heard of it? This abbreviation stands for long short-term memory, which is a bit controversial, how it can be long and short at the same time. But the idea is that if this mechanism is used, then the neural network is able to figure out which parts of the input in the whole text are more or less important for the output, for the understanding targets, for the understanding concepts, in the target language, in the transfer language, and then for generating something in the target language. So according to Ilya Sutskever, this LSTM mechanism introduced to Google Translate in 2014 helped it on the basics with recurrent neural networks already to start this process of developing, evolving machine translation on the new level. So how are these? By the way, do you remember Ilya Sutskever? Who is he? What do you remember about him?
It's the person from OpenAI, a Russian person that have an argument about T5 or 01.
Yeah, exactly. And so he's kind of the scientist behind GPT, but now he left OpenAI because of different inner conflicts. Right, and so in 2014 he still was in Google, and there he worked with this Google Translate mechanism. So let's look in more detail at LSTM, how it happens. So we're still discussing recurrent neural networks here, and this mechanism helps to analyze first the input. So here ABC stands for different parts of the whole text. Then it proceeds this information, these parts of the text to the layer, to the context vector, and then this context vector, it kind of tries to figure out most important parts of the input to be translated first into the transfer language, and only then the parts which are here illustrated as letters W, X, Y, Z are generated on the basics of this input, meaning that first of all this neural network is already bidirectional, and on the other hand, meaning that the text, the whole text, does not need to be absolutely the same as the input. The output text might be different in the grammar structure, in pragmatics for sure, and of course the vocabulary is also analyzed and used not just according to the equivalence, but mostly relying on the rules and collocations of the target language. So this mechanism was used before the transformers were introduced, but that was the first step with LSTM to try to work with this transfer language on the level of the text, first of all, and it helps to figure out the important things in the text, and to focus on generating new text in the target language, in contrast to doing just translation. Because of course, if we generate just a new piece of text on the basics of the concepts and ideas which we got, then of course the text would be kind of a better quality for sure. By the way, if we compare that to the statistical approach and even to the rule-based approach, that brings us to the so-called meaning text theory, which was developed by one of the pupils, so to say, students of Professor Lipunov, who proposed that the cohesion and coherence instruments tools within the sentence, within the phrase, should be analyzed. However, of course, with the statistical approach, it's quite straightforward because just the machine sees some patterns in the input sentence and tries to find similar examples, paying no attention whether something is important or not. Now, as we can see with the example, as we saw in the previous lecture with the example of Glocka-Kuzdra, of course, these weighting scores is not always, so to say, so successful. Nevertheless, in the case with machine translation, LSTM mechanism already showed some progress 10 years ago, but then after analyzing just sequences, so in LSTM based on recurrent neural networks, the architecture of sequence to sequence is used. So phrases and even parts of the text, like paragraphs, might be in the role of a sequence. However, then comes the attention mechanism with transformers, which is even more proficient in the figuring out the important things in the input. So here we have the input in the vertical line, so it is in French. And then we can see how it is at least visualized, how with the attention mechanism, the transformer, based on sequence-to-sequence architecture, but using T-to-T, tensor-to-tensor architecture, can figure out how to compare different parts of the input with some meanings in the transfer language and producing the output in the target language. So as according to the scheme, you can see that with different colors, they show the importance in terms of semantics and grammar and pragmatics of different words and different signs and numbers, so everything is weighted there. Nowadays, even a more successful mechanism is used. A new variation of attention mechanism is used in most machine translation tools. It is called cross-attention, which enables the process of analyzing different hidden states of the input of the encoder. In morphological analysis, it means that the parts of the words are tokenized, like in fast text, not as whole units, but as just a few letters in a row. And different variants of such unigrams are compared inside the transformer to figure out the grammar structure and to figure out the meaning of various parts of the words, partly from the semantic point of view and partly from the grammar structure. So here is the scheme that illustrates how one of the sufficient LSTM mechanisms works using softmax function in terms of attention mechanism, cross-attention mechanism, and this is taken from the BLSTM multilingual tool, which deals with two languages at a particular point of time, but in general is multilingual. It's really important for nowadays at least, for the machine translation tool to be multilingual, because the more languages it can operate, the more detailed the picture of a concept would be in its transfer language. And so the more effectively it would process the input. So to sum it up, here is the illustration of how different techniques developed, starting with the middle of the 20th century with rule-based approach. And we need to bear in mind that, of course, some rule-based techniques are still used in machine translation tools. However, they are enlarged by the statistical methods, which enable not just word-by-word translation, but analyzing on the phrase level, and which allow the data-driven approach, which is unsupervised, just figuring out the better outputs, relying on the corpus. However, even some specialists regarded statistical approach as worse compared to rule-based, because rule-based was rather controlled, whilst in statistical there was even more rubbish in the output. As for neural translation, the LSTM architecture, together with attention mechanism within transformers nowadays, help to process, to realize this vacuum triangle on all the levels of computing, vocabulary, grammar, and pragmatics, analyzing context, the broader context of the text on all the stages. Do you have any questions about these different types of machine translation? Then let's proceed with something more practical. So we speak about machine translation online tools. So in a few minutes we will do some pre and post editing with them. But what do you think? What does TM stand here for? These are professional tools, but what is important about them? What is the main feature which is different in professional machine translation tools? What can they do in addition to Google Translate? What do you think? Yeah, sure, but in fact, user-oriented tools, they also do that, right? That's another point, we will come to it, about simultaneous oral translation. What else? So if we translate with Google or DeepL or whatever, sometimes we feel that something is missing when we correct the results, for example. What do you think? Professional translators, what do they need to have in the system to make it more successful, more efficient? But editorial tools, they are also in the user-oriented ones. Any other ideas? In this abbreviation, T stands for translation. Translation something. What can be, starting with M, important for the translation system that would make the results better compared to just Google? Sorry? Models, but machine translation, yeah, okay. Motivation, that's a good attempt, but not exactly. Do you sometimes, do you use machine translation?
Yeah.
Yeah. Do you sometimes use it not just to get the idea of the text, but to, I don't know, to deal with the input then? Do you correct sometimes the results of translation? You edit them? What do you normally edit?
The translation.
Yeah, the translation. So what is normally needed, what is necessary to correct there?
When model can recognize collocation and try to translate it by words.
Yeah, sure. That's the most difficult still part of translating. Idioms, collocations, phraseologisms, it can't see. But for example, okay, let's deal with the idiom. You once corrected it, but the next day you would process another text on the same topic, and would it again make a mistake?
If it is a Google or something like GPT, it may be will learn.
Maybe, yeah, sure. That's the main thing. So TM here, translation, any ideas what might it be?
Tutor?
No. So what will, modification, very close to it, but still. So sometimes GPT and DeepL can remember what we did, but sometimes not. Memory, sure, yeah, it is memory, translation memory. So TM systems, translation memory systems, are used by professional translators. Nowadays, not many of them are free. Normally, they are paid because this is a professional tool. And so they provide two main features. The first feature is that you can add a glossary to the system, and it would follow this glossary. What is a glossary? A set of words or terms, so you can give it, you can feed it to the TM system, and it would consider that glossary and translate particular terms, for example, only this or that way which you already prepared. And the second thing is that it would remember all the previous translations made by a particular user, a professional translator. And so it would try to compare what it does at this particular input with the previous experience, taking into consideration not only mistakes corrected by the human, but also kind of style of this human, how they post-edit the text, and so on. That is why the translation memory system, it looks like this. It's not so important that it's okay just that a whole team can work on the same text, but it makes it easier. But the main thing is that it is quite interactive, as it, first of all, as it processes the text, the input, not just through its own layers of neurons, but it also processes and compares it to the translation memories of this particular user and to the term base or glossary that they provide for the system. They are also called these TM systems, translation memories, CAT systems, so computer-assisted translation. And the most popular one, at least for the pair Russian and English language, is the Smart CAT system. And in the notebook, there is a demo of this system. So if you are interested, you can watch this short video, like a few minutes, to see how this scheme is realized. So that was about professional translation memory. And this is a fish which was in fiction supposed to be kind of a simultaneous translator, meaning interpreting the oral speech. That was a little device that, according to fiction, could be put in your ear for to process simultaneous translation. So in 1980s, that seemed to be something from just fiction. However, nowadays, have you ever used simultaneous translation, machine simultaneous translation? Yes. What are the results?
I wouldn't say that I was disappointed, but I wasn't that impressed.
Okay, yeah, that's a good evaluation. So what was a bit disappointing, but what was okay?
Disappointed, maybe I chose the wrong text to, I chose like the wrong material to translate. Sometimes, maybe that's what I try to learn about languages. It's because in some context you need to understand the language very well to be able to interpret, is that the right word? To interpret the true meaning in the context of that material. Sometimes it requires a clear knowledge, not just of the language, but maybe the material itself, the context, the meanings that may be hidden in there, and sometimes knowledge of the writers, numbers of texts, in order to be able to fully understand the context. So I can't really blame
Yeah. Yeah, that's the main point, that nowadays the interpreting systems, so the systems which precede the translation of speaking, they are developing, because a few years ago they were absolutely like nothing. Again, in the notebook there is a list of best for today interpreting systems. Again, they are mostly not free. However, the main challenge for today's interpreting simultaneous machine systems is that it's very hard for them to translate a long piece of text. So if we have a dialogue and we exchange just 2 or 3 phrases, then it's quite okay. Obviously, the systems would manage with it. But if it's a long lecture, then it would, like in a minute or even in 40 seconds, it would get lost. So the hardest thing now for the oral interpretation is not to get lost, because the simultaneous interpreter, human one, of course, they do not try to translate word by word, yeah? So the competence means that they process this information as a whole. They kind of live in this long text, yeah, speaking. However, as for the machine, they still get lost if the speaking is too long. Nevertheless, seems like that they would overcome it, and so this Babel fish would soon be absolutely true, although the mechanism already exists and it really helps people lost in another country without knowing the language to survive somehow, but to process good simultaneous translation, good simultaneous interpretation for the conference, for example, they are not enough. Nevertheless, what do you think after when what happened in our world a few years ago that opened kind of a new era for simultaneous machine translation? So a few years ago, the new kind of level was achieved.
And today we can use delightful and if you listen us and give us a minute, we can interrupt them. Also, it will know the context of our life at all, because he has a memory of us.
Yeah, even he, not it, but already. Yeah, right. So in fact, as for the simultaneous translation, the period of COVID was the time when it started to develop very rapidly, because as you know, at different events and conferences, the simultaneous interpreter, they need simultaneous interpreters, they need a particular devices to process interpretation, but when all the conferences and events were online, the machine systems of interpretation started to develop very fast. Right. So that was about professional translation, professional interpretation, and now back to user-oriented systems, so online systems. Which online translators do you use? Yeah. DeepL, right. GPT for sure, right. Reverser, right. In fact, in the last probably 2 years, DeepL has been known as the best neural translator, but mostly if the target language is one of the European languages, when it's better to use Yandex Translator. For which pairs of languages? Yeah, if the target language is Russian, so it's better, of course, to use the system of the target language. So if we deal with Chinese, then which system is better to be used? Sure, yeah, right. So this is the main rule, that it's better always to use the system of the target language, because we need the generated text on the best level. As for GPT, compared to DeepL, it's not so accurate, but what are the advantages if we use GPT for translation? Yeah.
He speaks, construct a phrase at the moment, and it's constructed like a real phrase, real sentence, not try to translate each word.
Absolutely, so it's more human-like. It partly provides this translation memory within the chat, and also it is able to process some additional functions, like, for example, you can ask it to divide the text into particular number of sentences or paragraphs, so doing some additional language tasks. Absolutely, yeah. As for mistakes correction and editing tools, so Grammarly was mentioned. What other tools do you use to correct your text, to edit?
In Yandex Translator is GPT correction, but it looks like GPT works, but GPT works better. Also, DeepL in paid subscription has this function.
Okay, any other tools?
And the Microsoft Word.
Sure, right. Any other tools for correction? So DeepL was mentioned, Yandex, so within the translators, the correction tools are normally accessible. What else? Any equivalence of Grammarly?
In the phone.
Yeah, okay. But still, if we speak about full pre and post editing, again, we will use technologies on these stages of translation as well. Trying to prepare the text, first of all, for the translation, the input text, making it easier, correcting the mistakes, of course. And then on the post-editing stage, we need not only correcting grammar and vocabulary mistakes, but as well punctuation and pragmatic level taken into consideration. And I would say that in comparison to Grammarly, Paperpole, Quillbot, DeepL editor is now getting better and better, and I really like the part of it which was introduced just a few weeks ago, I think, that nowadays when it paraphrases the text, when it edits it, you can also ask it to use a particular style or tone. Normally, these functions are paid, but in DeepL they are free, and the limits of the words, it is unlimited on the whole for the day, and so you just need to work with paragraphs, so to say, and I would say that here DeepL is much better than all the equivalents. And I would say that again, even if compared to Quillbot, but it's quite just the question of taste, but I would say that the academic style is followed better. So it uses more discourse parameters there. Right, so that's what's important, that even Google Translate and DeepL, they are good, but we shouldn't trust them 100%. What we need to do is to prepare the text and then to post-edit it. So now the last thing for today that I would ask you to do, would you now take about 2 to 4 sentences from an article in your native language and translate them first by yourselves, but be sincere, translate by yourself. Probably you haven't done it in ages, but still try to, into English. And then would you use DeepL to translate the same few sentences into English? And finally, the third stage would be to edit in DeepL, the DeepL translation with a post-editing tool to edit it to the academic style, okay? And then you would compare your translation, DeepL raw translation, and post-editing to academic style and evaluate the result. Is it clear what you need to do? And in fact, if you copy what you do now, that would be your task after lecture 6, because you will have 2 tests now after lecture 5 and 6 to do. So partly we will cover this task, this home task. You will just need to add your answers which you process now to the platform to be counted, okay? Is it clear what you need to do now? So 3 operations with the same part of the text, but taken from an article or a paper on your research interest in your native language. You translate into English, first yourself, being sincere and honest, then with DeepL, and then you post-edit DeepL output, making the academic style, turning it to academic style. So take about, I don't know, 10 or 15 minutes to perform this task, and then we will compare the results, your evaluation. Okay, do you need more time for the task? No? A few minutes? No? Have you completed the task? Yeah? Right. So if you compare the 3 pieces of translation, what are your conclusions? So is anything good in comparison to DeepL translation in human translation? What is different? What are the advantages?
Well, I tried it twice. For me, I think digital translation was really good.
Mm-hmm.
And both times I think it was not exactly what I translated in my head. But to be honest, for DeepL way, it was the first time I used it. And I kind of like it so much. It's
Okay.
way better than my own translation.
Okay. Have you found the DeepL write function there?
Yes.
Yeah, right, great.
It was impressive.
Impressing, yeah, with the style editing as well, yeah, the change in style. Okay, right, okay, you're welcome.
I think if I compare my translation and DeepL translation, that I know the context better, and that's why maybe my translation will be more appropriate if we talk about translation, for example, the paper. And also, I found that if I'm translating what I wrote in Russian, I will separate the big sentences into, for example, 2 small sentences. Because I think that from make complicated sentences smaller,
Mhm.
divide them into two pieces. But DeepL will try to make the same hard and complicated sentence, which is, for me, I think not very, like, it's, there's no point to save the construction, this part of the construction. Maybe if I will write it in English, I will divide it, and it will be easier for readers to understand.
Yeah, well, we have this idea that it is more laconic English language in comparison to Russian, so yeah, okay, yeah. Yeah,
And
just
if I
about.
talk about DeepL for post-editing, I actually really liked it because it uses collocations and words which are very interesting, very academically appropriate. I would say. Like, it's a very, I don't know, elegant English. I don't know.
Okay, right.
Yes, so it's something that I will never think of when I'm translating.
Okay, right. As for my experience with DeepL Write, that was kind of the first time I've just edited one of my latest articles with it in English. And so it was the first time that it was accepted without the editorial request to add articles, because normally we all lack articles in the academic style, but DeepL managed with it in comparison back to Paperpole and Grammarly and others. They didn't manage with the academic style. Right, yeah.
The my translation and regular DeepL translation has a structure because I try to translate the requirements for course paper, like object, subject, and regular DeepL translate saves the structure, but DeepL Write in academic style delete all structure and make fluid sentences. And also, I think that my translation have more terms for psychology rather than DeepL translation. And DeepL Write also delete all terms.
So it still lacks this glossary, yeah? Okay.
It has terms, but it doesn't work with style.
Okay, right. Yeah, I think, yeah, that was quite a challenge. That was a good idea to give it such a structured text, because it probably, when it tried to make it academic, it tried to suit it to an article, and in an article, in a paper, it's better to avoid such a structure, kind of student structure, yeah? So probably that was, it tried it for the better, but not suitable for the particular text. Okay, right, yeah.
I have a question.
Uh-huh.
From scale 1 to 10,
Uh-huh.
how ethical it is to use DeepL Write to amplify my own text?
It's a huge question. We won't find the answer to it for sure. Even there are these interdisciplinary courses from the philosophical faculty, which you can attend next semester, which deal with the ethics of AI in general, yeah? Because this is a little question whether it's ethical or not to use post-editing tools. I do believe my point of view is that it's quite okay with post-editing, with pre-editing, with using some particular tools like Semantic Scholar or something. It's not ethical. It doesn't make any sense just to use GPT, which will generate a whole text for you. That's just doesn't make any sense. Yeah.
It's your main idea. It's just that it may have words that you wouldn't think of. It's like something that when you read, you will be like, oh, I can say something like this. But
Yeah.
it's just that I didn't think of it. It just sounds
Yeah.
better.
Yeah, I do believe the other thing about, in particular, post-editing systems is that if we just use GPT again to edit our text, it would never, if we do not particularly ask for it, it wouldn't explain to us any corrections. Yeah, but if we use these special tools, then we can even choose from the equivalence which it suggests. So then we learn together with them. So I do believe that it's impossible to avoid using AI. It doesn't make much sense because in the real world, your colleagues will use it, and so to be competitive in the market, you need to use it. Otherwise, you would do the same job, but with longer period of time. But of course, you need to put some effort at all the stages, human effort. Otherwise, we won't be specialists at all. Yeah.
Yes, I also wanted to add that there is an app called Notion, and there is also like an AE program that is in the Notion, and one of my groupmates used like IE Notion for like a Digital Drive for evaluating their diploma. And so I was thinking that it has like some pluses and minuses. Just because, for example, with the Notion IE, you can, for example, say something to the app, and they will translate what you are saying into the really good, really good paper. But at the same time, so it's easy for people who do not know, like maybe how to write beautiful text to use it. But at the same time, you need to learn something. You need to put effort. And so
Sure.
I don't know. It's interesting.
Yeah, it's a huge question about ethics. As for the evaluation of different translation systems, again, in the notebook, you will first find there is a link to a little Turing test for different translations in Yandex, but this is just Russian-English translation, not suitable for everyone, so you can just try it out at home. And as for the real systems, they are called blur systems, and also in the notebook, you will find some information about them, how they evaluate different tools for translating the same texts, because yeah, it's a huge field to be evaluated, to be compared. Any other impressions from comparing your translation to DeepL 1? Okay, fine. So then thank you very much. So you probably performed the task. On the site, I would ask you to add to your answer all the 3 translations and your evaluation. I won't ask you to add the input text because I do not know all your native languages. It doesn't make much sense. I won't be able to compare them. Any questions? So do not forget, you will have a bit more time as you've already done this translation task. Do not forget to complete your TXT corpora before the next lecture, because afterwards we will work on them. Okay? Right, so thank you very much. Bye-bye.